Good morning, and here is at least the first part of the lesson 4.1. We're starting out in trigonometry, and you'll learn how to describe an angle and to convert between degrees and radians. So first off, the word trigonometry, it means measurement of triangles, but we're going to talk about in class tomorrow that it means so much more. So even though trigonometry means the measure of triangles, we start right off talking about the central angle of a circle, and we're going to wait and define some of these terms. I'm going to wait on that one, but complementary angles, those add to 90 degrees. Supplementary angles, it's a little review from geometry, those add to 180 degrees. A degree is 1/360th of a circle. And so we're going to be in our discussion today using lots of words that have to do with angles. So the way we determine an angle is we rotate a ray. We say we rotate, or an angle is determined by rotating a ray about its end point. And the initial side of the angle is the starting position. And the terminal side is its position after rotation. So I can start my initial position anywhere, and then I could rotate it counterclockwise, which is a positive direction. And so this would be my initial, and this would be my terminal ray, or terminal side. And I could also start it in that same position and rotate it clockwise. So this is counterclockwise, and that would be a positive angle, a positive rotation. Counterclockwise, or clockwise, and then this would be the terminal side. And this is a negative angle. So clockwise is negative, counterclockwise is positive. The vertex of the angle is the end point of the ray. An angle is in standard position when the initial side coincides with the positive x-axis. So the initial side coincides with the positive x-axis. So if I were to draw my coordinate plane, then let me use a different color. So if my initial side is right here, then that is in standard position. And that's really a lot of the angles, most of the angles we'll be talking about in trigonometry. I said a positive angles generated by a counterclockwise rotation, which is this way, and a negative angle is generated by a clockwise angle or rotation. If two angles are coterminal, that means they have the same initial and terminal sides. So to give you an example of some coterminal angles, I'm going to sketch angle alpha on my same coordinate plane right here. So say this right here is alpha, and I'm not even going to give it a degree measure. But what can happen in trigonometry is that we might make more than one rotation. And if you guys have been watching the Olympics at all, you have seen those snowboarders make multiple rotations, 360s, 720s. I think they're up in the thousands of degrees once they rotate a 1080. That's rotating 3 times. So if I go all the way around my circle and then I end up in the exact same place, those are two, I would call that one angle beta. Those are 2 coterminal angles. So in trigonometry, and we will go into why this is so, but we are going to be dealing with radian measures. So you've learned degrees since you were young, and not sure if you covered radians in Algebra 2 or not, but we are going to be dealing primarily with radians, and I'll go into class with why that is so. But in radians, the measure of an angle is determined by the amount of rotation from the terminal side, or from the initial side to the terminal side. And 1 radian is the measure of a central angle, and this is Greek letter theta, that intercepts arc S equal to the length of the radius of the circle. So algebraically, we have a little formula that we can use. Algebraically, theta equals S over R, where S is the arc and R is the radius. A central angle of 1 full revolution counterclockwise corresponds to an arc length of, and so if we picture that, 1 full revolution is the distance you would travel around. That's the circumference of a circle. So that's going to correspond with the formula that we've always used for circumference, 2 pi r. So the radian measure of an angle of 1 full revolution is 2 pi radians. A half revolution corresponds to an angle of pi radians. So if you think about it, you go all the way around, that's 2 pi, so half must be half of 2 pi, which is just plain old pi. A fourth of a revolution, well, if I cut pi in half, that would be pi over 2, and a sixth of a revolution corresponds to pi over 3 radians. And we're going to go into all of this in class tomorrow in great detail. So we're just covering the basics right now. So angles with measures between 0 and pi over 2 radians are called reference angles. And we also need to think of those as acute angles. If you think about where pi over 2 is, that's right there. So pretty much that's right at the 90-degree angle. Angles with measures between pi over 2 and pi radians are obtuse. To find an angle that's coterminal to a given angle theta, you're just going to want to subtract 2 pi from it. So here I've got, let's see, if it's greater than 2 pi, you're going to want to subtract 2 pi. If it's negative, you're going to want to add 2 pi. Let me see if I can find a better formula for that. Let's see. So in the book it says add 2 pi n, where n is any integer. So if we're going to find an angle that's coterminal with negative pi over 8, I want to add 2 pi to that. So using fraction rules, if I want to get a common denominator, I would just multiply by 8 over 8. So that's negative pi plus 16 pi, which is 15 pi over 8. Find the supplement of pi over 4. Well, supplementary angles, they add up to 180 degrees, or in radians, they add up to pi. So if I have pi over 4 plus theta equals pi, then I just need to subtract pi over 4 from both sides. So I get theta equals 3 pi over 4, or 3/4 pi. So degree measure, that's the, and actually I have to see, were you even able to see any of that? So let me go ahead and move my screen down, and you can pause it and copy the notes just in case that did not show on the screen. Sorry about that. Okay, now going back up into degree measure, a full revolution counterclockwise around a circle, we have learned since, I don't know what grades, 3rd or 4th grade, 360 degrees. And then a half revolution corresponds to 180 degrees. To convert degrees to radians, you simply have to multiply by pi radians over 180 degrees. And to go the other way, to convert radians to degrees, multiply by the conversion factor, which is 180 over pi, and that's degrees per radian. So if I want to change 120 to radians, so I have degrees and I want radians, so I'm going to multiply by pi over 180. And I'm going to use my multiplication rules, which we talked about heavily in the last chapter, to cross cancel. 60 goes into both, 60 goes into 120 twice, and into 180 3 times. So I get 2 pi over 3. If I want to convert 9 pi over 8 radians, then I need to go the other way. I need to multiply by 180 degrees per pi radians. So fortunately, all the pi's are going to cancel. And then I want to cancel my 8 and my 180. And so what goes into both? I'm going to start with, I believe 4 goes into both. So 4 goes into 8 2 times. 4 goes into 180 45 times. So now I have 9 times 45 over 2, which is going to be, let's see, 405 over 2, or 202.5 degrees. So you can attempt to complete this table. I am running out of time this morning, so I would like for you to be able to, as a try it, complete this table. For example 5, converting the degrees to radians, or if you're given radians, convert it back into degrees. And then we will talk about linear speed and angular speed in class on Wednesday. So that is all I have for you with section 4.1, your introduction to trigonometry.